basketball during the championship game, and she needs to get to the basket as quickly as possible. Being MVP, there's a lot of pressure for her to make these final shots, as it determines which team will win. Mascot Lauren is cheering her on with a hearty, "You got it, girl," from the sidelines. Brooke calls timeout. She runs over to Coach Jen, who will tell her the next play. Just then, student Meredith runs over screaming, "I need help with my calculus homework." Heroic Brooke yells, "I can help." With 15 seconds left in the timeout, the pressure is on. Here's the problem. An FBI agent with a powerful spyglass is located in a boat anchored 400 meters offshore. A gangster, under surveillance, is walking along the shore. Assuming the shoreline is straight and that the gangster is walking at the rate of 2 kilometers per hour, how fast must the FBI agent rotate the spyglass to track the gangster when the gangster is 1 kilometer from the point on the shore nearest to the boat? Convert your answer to degrees per minute.
Ready, go. The underlying independent variable is time, and the independent variables are x and theta. For starters, we will measure all distances in meters, times in hours, and since we are doing calculus, all angles in radians. In these terms, our problem is the following. Given that dx dt equals 2,000 meters per hour, find d theta dt when x equals 1,000. Our answer will appear at first in radians per hour, which then must be converted to degrees per minute.
Since the triangle in the figure is a right triangle, the variables x and theta are related as follows. Tangent of theta equals x over 400.
By differentiating, we find the following relationship between the variables and their rates of change. Secant squared theta times d theta dt equals dx dt divided by 400.
Since the secant is the reciprocal of the cosine, this can be written as follows. D theta dt equals dx dt times cosine squared theta divided by 400. Now we consider the instant when x equals 1,000 meters. We must compute cos squared of theta and substitute this number into the equation for d theta dt. Using our reference triangle and the fact that cosine is equal to the adjacent side divided by the hypotenuse, we find that cos squared of theta equals 400 squared over 1,000 squared plus 400 squared.
We are also given that dx dt equals 2,000 miles per hour, and so we substitute and compute. You can verify that the result is the following. Derivative of theta over derivative of time equals 2,000 times 400 squared divided by 400 times 1,000 squared plus 400 squared. This equals 20 over 29 radians per hour.
The conversion to degrees per minute is accomplished as follows. 20 radians over 29 hours times 180 degrees over pi radian times 1 hour over 60 minutes equals 60 degrees over 29 pi per minute. In other words, the agent's spyglass must rotate about 0.66 degrees per minute to track the gangster.
Oh, now I see. Thank you, fellow mathletes.